Management best practices. There's the ability to back up single databases or groups of databases or a whole instance. And in fact, in the UI, we actually present things exactly that way. So for those of you familiar with UI, which hopefully is everybody, if I just jump over to one close those. You'll see that under Application Manager and under App, I see SQL instances. Under the SQL instances, I can select one, and I can see all of the databases under that instance. And I have the ability right on the instance to go ahead and apply a template and a profile. And if I do this, just by default, out of the box, every database in the instance will get backed up, all as a single job with this template and using this profile. In fact, any new databases that show up will automatically get backed up with this template and this profile. Any databases that are deleted get ignored on future backups. They still show up on the list over here, but they don't cause any problems, right? That's the SQL instance management capability that we introduced back in 7.1, I believe it was. So that functionality is there. It has become very popular since deploying it. Now, the default behavior is include everything. But for those of you who were customers before this feature was out, you know that you can also simply pick a database, and then on that database, you can apply a template and a profile. Or you can put databases into a group, because if you group them together, it's more efficient use of resources, and specifically virtual disks. And I mentioned the way we carve out disks is, if I've got a D, an E, and an F drive, and that have my MDFs, NDFs, and LDFs, and I back up a single database, I'm going to carve out 3 disks. But if I back up a group of databases or the entire instance, I'm still going to carve out 3 disks. So it's much more efficient to back them up in groups than to carve out a bunch of disks for each one. So clicking here, for example, I can see this one is in a group, SQL Server group, and that's going to be listed under groups. So I go to groups, I can see my SQL Server group, I can see the databases that are inside of it. And here's where I applied my template and my profile. Now, back on the SQL instance side, I said that the default behavior is to include all of the databases, but that's definitely configurable. So if I come into select the SQL instance itself, you'll see I have a link here called Manage Membership. And in here's where I define the database inclusion rules, if you will. What database or databases should be included when I run a backup at this quote unquote instance level. And you can see the way it's been defined here is I have the ability to say all databases, and that's what it is by default on a new discovered instance, a new server. I can say all system databases or all user databases. I think those are pretty clear to anyone familiar with SQL what they are. Those same options exist in native SQL maintenance plans. Or I can say selected databases. And if I say selected, I have a further choice to make, exclude or include. And if you think about this, it makes sense, right? If I say selected databases include, and I select some databases, I'm basically doing the same thing as if I just created a group and put those databases into it. There's nothing dynamic about it. I have told the system, include these databases, and that's it. And if I hit the help icon here, you'll see that it'll say that as well. All the databases selected below will be included in the data capture if the policy template is applied to the SQL instance. Databases added to this instance after selecting this option will not be included in the data capture. Of course not. They're not included. They haven't been selected. On the other hand, I can say exclude, and this is the more common option, is either to say all or to say selected and exclude and choose databases to exclude. And in this case, I've said exclude report server and report server tempdb, but anything else is included. That means in this example, MSDB model and master. It also means, and this is probably the most important thing, any new databases that show up will be included in the data capture for this instance, right? It is now dynamic rather than static. Now, down in the bottom, I have ineligible members. These are databases that fall into one of 3 categories. They're either A, protected individually, and I can see small DB, which I had selected before, that one was protected individually. They are in a consistency group. 1, 2, and 3 were in that consistency group that I showed you. Or they might be mounted from an existing, from an appliance. They're not really part of the instance from a disk standpoint, from a backup standpoint. They're running off of Actifio disks. And because of that, if we want to back them up, we don't want to back them up in a group with all of the rest of the instance. We want to back them up in their own group, because if they are only backed up as with other databases that are mounted from an appliance, we can use a more efficient capture method. Instead of using the change block tracking and copy the data to a staging disk, well, we'd just be copying it back into the same pool of disks that it's already running off of. It's running off of an Actifio mount. So instead, we just do a quiesce and a snapshot and an unquiesce, and we actually snapshot our underlying disks. So it's a significantly faster process at that point. So 3 levels of protectable applications: database, consistency group, and SQL instance. When you want to decide which one to use, you want to consider things like the vdisk consumption, like I mentioned before. You typically don't apply protection to all of the databases individually. It consumes vdisks, and vdisks are a limited resource on an Actifio appliance. It could end up in driving more Actifio appliances than you want to have, which just complicates administration. Retention and backup schedule. If you have groups of databases that need a different retention, well, that's when you might group them into consistency groups and run those backups with different policies, use different templates, or have different retentions. And then, of course, consistency point. And this one doesn't matter so much anymore, but in the past, a lot of people said, you know what, I have these 6 databases for the same application. I want to make sure they get snapped together. The reality is, when you can, in a single command, recover databases to the same point in time using the logs, it doesn't matter so much if the backups happened at the same point in time or not. And then you add to that the fact that you can't get a consistent point across multiple databases that exist in different servers, and then that just further complicates things. So again, transaction logs to the rescue. You really don't need so much these days to have a consistent point in time for backup from multiple databases, so much as the ability to recover to a consistent point in time. Best practices for backups for SQL Server. A, use the SQL instance level by default. It's dynamic, right? And that's the whole point about why we added it. New databases can automatically be backed up, and 9 times out of 10, that's what you want. Use consistency groups only if you need to. A, if you're already using them, you don't have to turn them off. They will continue to work just fine. You can continue to use them as you have, especially on existing servers, but maybe on new servers, start using the SQL instance instead. B, funny timing on the question there. If you're using SQL Server Always On availability groups, and as I said a few times, next week we'll have more detail on that. Or C, and this is one that's not very oftenly encountered. VSS has a limitation that if you try to quiesce databases that require more than 64 disks to be snapshotted at once, it will refuse. It only has the ability to snap up to 64 volumes, or mount points, drive letters, etc. Obviously not drive letters if it's 64 at once. So if you do have a large environment, we do have some customers that have over 100 volumes, 120, 130 volumes on a production SQL server. You can't back up all of those in one shot. So at that point, you separate them into consistency groups, probably based on the disk layouts, so that you minimize the number of disks that need to be snapped as a part of any single job to be under that 64 threshold. And then finally, protect to the individual database level. Really, this is for those special databases only. You need to separate for security reasons a particular database that's sensitive, and you want to assign it a different organization membership, or you have a radically different SLA, backup schedule, recovery schedule, etc. I honestly don't see this being done very often. It's almost always consistency groups and instances. When people are backing up individual databases, it tends to be for testing purposes more than anything else. And then finally, on the management side, transaction logs. Best practice on transaction logs and backups and frequencies. Most customers run their database backups once a day, and then they run transaction log backups more frequently depending on their required RPO. Most often I see about 2 hours in there, which is the example that we have on the screen. You set RPO to 2 hours and you set your frequency or your retention, sorry, to whatever you need it to be based on your company's policies. Just keep in mind that a long retention of logs does consume disk. You know, I've had a couple people say, I want to keep 21 days worth of logs or 30 days worth of logs to get point-in-time recovery all throughout the 30 days. You can do that, but just make sure you're sizing it accordingly based on what your daily log generation, size is. We also have an option. I didn't put it on the screen here, but there's an option for you to choose if you want your transaction logs compressed. I think by default, I think it is not enabled, but you might want to consider enabling it. Or if it, I don't actually remember what it was. I think we were gonna make it compressed by default, but we didn't want to change existing behavior for existing customers. So you might need to go manually turn it on. But if you do compress your database logs, it's actually SQL Server doing the compression, not Actifio. And what that means for you is it means that down the road, if you wanted to do a mount and mount up your transaction log backups and manually process them using T-SQL commands for some reason, you still can. You don't need Actifio to decompress those logs. They were compressed by SQL Server, and SQL Server knows how to decompress them when you access them. And then finally is replication. And this one is probably fairly obvious. If you want point-in-time recovery at a remote location, replicate the transaction logs. They get replicated to the same place that the database gets replicated to, and they have the same retention that the database has at that on both sides. I should say they have the same retention. The transaction logs have the same retention on both sides. It is independent of the database retention from a retention in that snapshot pool, and that's because you can do things like a mount. If you've got 2 days retention in snapshot and 2 months in dedupe, you can do a mount of an image from dedupe that's a week old and use the transaction logs to roll forward to a specific point in time. That is absolutely allowed. So final topic here is accessing the data. So to access the data, you have two basic concepts, mounts and restores. So the word recover is an interesting one that we try to use a lot because people associate it with restore mentally, and restore is what all of the legacy backup and restore products called it. Obviously, they're backup and restore products, but we prefer the word recover because it is so rare these days that customers need to do an actual restore. In fact, in Actifio terminology, a restore means put the data back where it came from, right on top of the original source. If you want to access it on a different server and you actually want to copy the data to a different server's disks, until recently, that wasn't even available in our product natively through the UI. You had to do a mount and copy it either with a command line option or using Windows Explorer because the flexibility of mounts, the performance of mounts is such that 98% of the time you need to access a backup of your SQL Server data, you don't really need to copy it to the target server. In fact, you don't want to copy it to the target server. The bigger the database, the more true this is, right? Imagine I've got a 10 terabyte SQL Server database, and I need to do some investigation off of a backup. Do I really want to call my storage admin and submit a request to allocate 10 terabytes to the SQL Server that I'm going to do this on, and then wait until it's allocated and ready, and then trigger from my backup team a restore to copy all of that data there and wait all of that time as well, just to run a few queries and then say, okay, you can clean it all up? You know, that's a lot of work for people and a lot of time and process. Instead, the QA person or the support personnel could be given self-service access to spin up that 10 terabyte database on their SQL Server. And we'll simply present the disks that already have it on there on the fly, bring the database online to the point in time they want. They can run their queries, and then they run an unmount, and it takes it out. So 98%, at least my personal experience, 98% or more of recoveries don't involve really copying any of the data. For that 1 or 2%, it's important that you can do it, and you can. we added specifically for availability groups a feature called clone. I'm going to talk more about that next week, but clone is the way that we copy data to a target server that's not the original target server, the original source server. And I'll dive into details on that one next week as well. But that's just probably the biggest thing to keep in mind is how often you do what type and why. And so once you get that, the what you want to do is very clear. You do amount almost all of the time. Whenever you need to access the backups, it automates the things that you want. You don't have to wait for storage. You don't have to wait for data to be copied. And you can even use it for beyond recoveries, but for creating test environments and QA environments. You can have these mounts persistent for some time. They can be there for weeks, sometimes months. Isn't uncommon to see. When you do a restore, well, restore is old school, right? It's the 1%, 2% where it's going to copy all of the data back again.
Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.